All right, so to continue on, we're in the section 2 of our Unit 5 notes. What we're going to be working on today is the polygon angle sum theorem. So we're going to talk about what polygons are and kind of how many degrees they add up to. So a polygon is a closed plane figure where all sides are segments. Now, what that means is a closed plane figure, that's just a two-dimensional figure. All the sides also have to be segments. So let's first talk about what isn't a polygon. A segment or two segments connected, that's not a polygon because it's not closed. Think of the term closed like a fence. You know, you want to keep all the animals inside of your segment fence, and it can't be open. So just because it has, three sides, that's an open figure. It also can't be like a circle. Those don't have segments. All sides have to be segments, like they have to be sides. Also, a half circle, that would count too, because just because it has a segment, it's still incorporating a curve. Also, it can't be crisscrossed like this. It kind of just has to be open, like this kind of shape. Also, it can't be three-dimensional. So a closed plane figure means two-dimensional. So for example, a triangle. Three sides is the smallest. You can have this kind of weird shape. That's a polygon too. But think of it in terms of like a fence. You want to keep all your animals in, and your sides have to be segments. Now the term regular polygon means all sides are congruent and all angles are congruent. It's basically like a square. All the angles are equal, all the sides are 90. Sadie, just got that chew toy again. Now, some important things that we want to make sure that we know. The names of figures. Now, when it comes to shapes, you have to know their names. The most common ones that the ACT expects you to know is a three-sided figure, is a triangle. Four-sided is a quadrilateral. 5 is pentagon. 6 is hexagon. They expect you to know octagon, which is 8, so 7 sides is heptagon. And then a decagon is 10. Nonagon is 9. 11 is a hendecagon, and 12 is a dodecagon. Usually anything past that, we call it an n-gon. So what that means is, let's say it has 27 sides. We would call that a 27-gon. So a polygon means poly meaning many, and gon meaning like side. So a 27-sided figure would be called a 27-gon. Okay. There are technical names for every single type of sided polygon, but I don't expect you to know that. I mean, obviously, up until 12, that's plenty. You don't have to learn every single name for every single polygon in existence. So 12 is a dodecagon. So from here, number of sides is how many sides the shape has. The reason 3 is the minimum is because one side would be a segment. 2 sides kind of is an angle. 3 is the minimum that they can connect. So that's why you have 3 sides. So let's learn the polygon angle sum theorem. And we've already learned the triangle angle sum theorem, which is how many degrees a triangle adds up to, which we all know is 180. However, you need to know how many degrees are in all kinds of polygons. So let's write the formula and discuss how to create it. So the formula is parenthesis n minus 2 times 180, and that gives you total degree, how many degrees a shape has. Now, the letter N is going to stand for the number of sides. Number of sides. So let's practice. This is a 4-sided figure. The number, or the section here, N minus 2, this is going to stand for the number of triangles a shape has. So what that means is whenever you're creating the polygon angle sum theorem, you draw what's called diagonals. You pick a vertex and draw segments to all other vertices. So up, over here, over here. Notice how many triangles are created. We have 2 triangles, a triangle here and a triangle here. Well, each triangle adds up to 180. So 2 triangles times 180 is 360 degrees, which is how many degrees are in a quadrilateral. Let's continue this trend. I'm going to pick this side up, over here, and over here. That gives me 3 triangles. 1, 2, 3. Well, 3 triangles with a total of 180. 3 times 180 is 540. And 3 times 180 is 540. So a pentagon has 540 degrees because each triangle has to add up to 180. So 3 180 degrees is 540. Let's try one last one for a, let's see, 2, 4, 6-sided figure, a hexagon. I'm going to pick any vertice I want. I'll pick this one. Draw lines to each other vertex. These are called diagonals. And then I'm going to count. 1, 2, 3, 4. So 4 triangles with 180 degrees each. So 4 times 180 is 720. So every single 6-sided figure, a hexagon, adds up to 720 degrees. Now, the n minus 2 times 180. N minus 2 is the number of triangles in a shape. So notice here how we have 2 triangles. The n minus 2, the reason that it's subtracting 2 from the number of sides is because whenever you're creating your diagonals, you're tracing 1, 2 sides. You can't count these 2 sides when making the triangle. Same thing here, 1, 2. 1, 2. So you have to remove 2 of the sides because they don't actually make triangles. You're just tracing side lengths. So up until this point, the n means number of sides. When you subtract 2, that gives you how many triangles are left. The 180 degrees comes from degrees in a triangle. So all of this is kind of based on triangles. Using the formula, we can easily do n minus 2 times 180. Well, 4 sides minus 2 gives me 2 times 180, 360. So that's exactly how the formula is created. N minus 2 times 180 is just based on number of triangles in a shape. Now, this becomes highly unrealistic when you're dealing with a 70-sided shape. No one wants to do like 70 diagonals and counting. It's a lot easier to do, well, 70 minus 2 is 68. And then 68 times 180 gives me my total. So the polygon angle sum theorem, okay, polygon angle sum theorem is how many total degrees are in a shape. So when it says find how many degrees the interior of any polygon adds up to, I'm going to be utilizing the polygon angle sum theorem because what that does is it finds a total. Okay, so let's practice. We want to know how many total degrees are in a dodecagon. So the first thing I have to analyze is how many sides the shape has. Dodecagon has 12 sides. So n is 12. I want to know total degrees. All I'm going to do is 12 minus 2 times 180. And what you're going to make sure that you do in your calculator is put it in parentheses. So 12 minus 2 times 180 is 1800. Also, 12 minus 2 is 10, meaning if I had a 12-sided figure, I could draw 10 triangles in it. So 1800. Okay, let's try another one. Hendecagon. Using my chart up above on the top, that's 11 sides, so n is 11. So 11 minus 2 times 180. Notice the pattern here. It's always going to be number of sides minus 2 to create number of triangles times the 180 for each degree. So it's 1620. So there's 620 degrees in each triangle. All right, let's continue. 25 gone. Well, that's easy. N is 25. So I'm going to use my formula. 25 minus 2 times 180. 25 minus 2 times 180 is 4,140. Okay, and last one, nonagon. A nonagon has 9 sides. So n minus 2 times 180. So 9 minus 2 times 180 is 1260. Now this works for any shape. It doesn't matter if it's a regular polygon. Any 25-sided shape will always add to equal 4,140 degrees. Doesn't matter how big or small the shape is, how you draw it. It's just like a triangle. All triangles will always add up to 180. So let's utilize that information to help us find the measure of one angle in a regular polygon. Okay, so thinking about the method, we want to find one angle in a regular polygon, meaning all the angles are the same. We want to find one of them. The first thing that you have to do, we got to find the total. I can't find 1 degree or one angle measure until I know how many total there should be. So a nonagon has 9 sides. So 9 minus 2 times 180, which we did right up above, which is 1260. That gives me my total. Now, the second thing I want to do is find one angle. Well, if I want to find one angle, what should I do with my total if I have 9 angles and I just want one? I should divide by how many angles there are, which is 9. So 1260 divided by 9 means each angle is 140 degrees. So when you're trying to find one angle, you have to find the total first. Then you just break it up into how many pieces there are. One angle in a 9-sided figure, I want to divide it in 9. Okay, if I have 1,260 chicken nuggets and I've got 9 friends, that's a lot of friends to have, you know? I've got 9 friends. I want to break that up evenly. I would divide my total by how many friends I have, and then we would each get our share. So mathematically, you're using the same formula to find how many one angle measure is, but in order to do that, you just divide it. So let's continue. One angle in a regular hexagon. So using our chart up top, hexagons have 6 sides. So first, I need to know the total before I can break it up. So 6 minus 2 times 180. Okay, so parentheses, 6 minus 2 times 180 is 720. So all of my angles in my hexagon add up to 720. I only want to know one of those angle measures. So I need to break my 720 into 6 equal pieces. So 720 divided by 6 is 120. Now you might get decimals in here, so it's okay, round to the nearest tenth. So one angle is going to be 120 degrees. Let's try the last one. One angle in a regular decagon. Decagons have 10 sides. So again, I need to find the total before I can just break it apart. So 10 minus 2 is 8. So you can do 10 minus 2 times 180 just all together. Or you can do, okay, 10 minus 2 is 8 times 180. You can do it either way, whichever is faster for you. So 1,440 is my total. Now again, I want to break this into one angle. So in order to do that, I have to divide by 10. So one angle equals, well, 1,400 divided by 10, or 1,440 divided by 10 is 144. So one angle is 144 degrees. Remember, we're utilizing the same formula. N minus 2 times 180 gives me the total. If I want to break that total up, I just divide. In our next video, we'll finish up on page 16.